Hello and welcome to Lesson 3.2 Transformations of Absolute Value Functions. So continuing our learning from yesterday where we introduced you to absolute value functions, today we are talking about the transformations of the functions, which actually is just talking about the different changes to the parent graph. So that could be translations, it could be reflections. Those are really the only two that we get into. And then these are changes to the parent function. So that includes translations and reflections. And just as a reminder, our parent function is the absolute value of x. All right, so our learning target is that you can describe the transformation of a graph where parameters are changed. You'll be able to describe vertical and horizontal shifts. You can describe the vertical compression or stretch. You can identify a vertical reflection, and you can write the absolute value equation based on the transformation from the parent function. All right, so let's get into it. This is the vertex form we talked a lot about yesterday. This is vertex form. I apologize ahead of time. My dog is crying and begging for me to, there's one, begging for me to pet them. So bear with me with the dog noises. Okay, so getting into our vertex form. All right, so this first box here, it is pointing to the positive and negative sign. And the positive and negative sign is going to tell us two different things. If it's positive, then we have no change. No change happens if this first value in the front is positive. Now, if the first value is negative, then we have a reflection across the x-axis. All right, and what that looks like, just to give you a little visual, if this was our coordinate grid and this is our absolute value function, this way is if it's positive, and this way if it is negative. So this bottom one would be what the reflection is. This top absolute value is reflected across the x-axis here. This is x and this is y. Yeah? Okay. So next here, focusing on the A value. The A value tells us about any vertical transformations. So again, the A value represents vertical transformations. If this A value, if A is equal to 1, there is no change in the parent function. At least a vertical change. There's no vertical change in the parent function if A is equal to 1. Now, if our A value is less than 1, then our graph experiences what we call a vertical compression or shrink. Vertical compression or vertical shrink. And I'll do, again, another little visual here. So let me see. If this is the x and this is the y, let's say our parent function looks like this. The new graph would actually be wider. So I know it says compression or shrink, but when we think about compression, we think about compressing down to the x-axis. Compress towards x-axis. Okay, now for our final possible a value, if a is greater than 1, then our graph experiences the opposite of a compression or shrink, but a vertical stretch. And when we think about vertical stretch, I want you to think about that early morning stretch. As soon as you wake up and you reach up really, really high and your legs get really long and you stretch your whole body because it's early in the morning and you're like, ah! That's what's happening to our graph. So if this is our graph here with x and y, and let's say this is our parent function. Okay. Let's say that's our parent function. The graph is actually going to get narrower. So over here we can say we're stretching up like a good morning stretch. I'll put good morning stretch. But also gets narrower. Narrow. And I guess if this one's getting narrower, we can say that this other one here is getting wider. Okay, hopefully you can see that all right. Wider, narrows. Okay. All right, so for this next box here, we have our H value. Oh, let me go back actually. The A value and the positive or negative, we want to imagine them as two different things, two separate entities. If it's positive or negative, it has no change. Sorry, if it's positive, it has no change. If it's negative, then it's a reflection. And then we want to look at the A value as a separate thing. Because let's say, for example, our A value, let's say don't write this down, but let's say our function looks like this. We don't care what the H and K are. But let's say our A value in the front is a -3. Now, -3, that number, if it's negative, it is less than 1. But we can't think of them, the negative and the 3, as one entity. Because really what we have here is a 3, oops, a 3 for letter A, which means we're getting a vertical stretch, and a negative, which means it is also reflected across the x-axis. So please separate the two. The negative and the A value are two separate things. When we're talking about if the A value is less than 1, right here. When we're talking about if the A value is less than 1, we're not talking about whether it's a negative number. We're talking about if it's like a fraction. Sure, 1/2 is definitely less than 1. But a 3 is definitely larger than 1. So different things would be happening, and if you imagine those two items together as one, you're going to get a lot of questions wrong. So these are two separate entities. All right, moving on to H. With H, we need to remember that X lies. But before we get in that, let's write at the top, these are horizontal transformations. Oops. Transformations. So with the horizontal transformations, yes, we do remember that X lies about H. So when we see if in the equation it reads X minus H, we know that h is really positive. And because it's positive, that means we are shifting to the right. All right. And if the equation looks like x plus h, then we know we really have a negative h. And because it's negative, we shift left. Okay, so again, what I drew here, oh, don't do that. Here and here is what it looks like in the equation. So if the equation reads x minus h, we know it's actually positive and it's shifting right. And if it reads x plus h, then it's really shifting to the left. All right, moving on to our last one, which is another vertical transformation. So because k is a vertical transformation, when we have a positive k, we shift up. Oops. Shift up. And when we have a negative k, we shift down. So k is exactly what she says she is. Unlike x, he's always lying about who he hangs out with. Okay, so moving down to our parent function, down here it says parent function f of x equals absolute value of x. We did go over that yesterday. Now, okay, so here we want to identify these four things. First, is it plus or minus? Well, do you see a negative out front? No, so it's positive. Now, what is the a value? Well, the hidden number here is a 1, as always. So a value is 1. And h is always inside that absolute value, like right after the x there. Since there is no h, we assume it is 0. And since there's no k being added or subtracted to the back, again, it is 0. So in this next box, we're going to say all transformations occur from the parent function. Okay. Moving down, we are almost done. Describe the transformations of the functions from the parent function f of x equals absolute value of x. So starting with this first one here, is this a positive or a negative graph? Well, we look out front right here, and we have a negative sign. So we know this graph is negative. What happens when the graph is negative? Let's look back up at the top. Negative means reflection across the x-axis. Let's go ahead and write that here. Reflection, sorry, I'm so sorry, y'all. Okay, reflection across x-axis. All right, let's look at A. Now, what is our A value? There's no number there, so we assume it is 1. Well, I guess we're not assuming, we actually know, because when there's no number in front of in front of a variable, it's always 1. So when a is 1, what happens? Right here, a equals 1, no vertical change. Excuse me, no vertical change there. So no change. All right, let's take a look at the next one. H. What is our h value here? It says positive 1, but we remember x lies. So h is actually -1. And when it says, and we can look back at our notes too, it said x plus h. So x plus h is right here. So we know h is actually negative, and it's going to shift left. So we can say shift left. How many is it going to the left? 1 unit. Great. All right, the k value. K is always at the end, and there's nothing on the end here, so the k value is 0, which means there is no change. All right, and then at the bottom, we didn't put the vertex on here, but I want us to identify the vertex. Remember, the vertex is always h, comma, k. So what is our h value here? We said h is -1, and our k value is 0, right here. All right, moving on to the next one. Here, again, is this graph positive or negative? We look at the front. There's no sign here, so that means it's positive. So we say positive, and when the graph is positive, the graph experiences no change. Go ahead and go back down and say no change. Okay, now look at the a value. Our a value here is 5/4. Now, what's important to know or to ask is whether this number is greater than or less than 1. Okay, so a 5/4, is that larger or less than 1? It is larger than 1. So since 5/4, our a value is greater than 1, let's take a look up here. A greater than 1 means vertical stretch. We said that's like the good morning stretch, which means our graph narrows. It gets narrower. So down here we can say vertical stretch. Now for the h value, what is our h value here? That's right, it says 3, which means it is -3. And when h is negative, we move left 3 units. And our k value, lastly, our k value is -2. So that means we are moving down 2 units. So what is our vertex here? Our vertex is hk. So here, that is -3, comma, -2. All right, let's move on to the next one. Now, is this graph positive or negative? It is negative. That means, let's look at the top again. Negative means reflection across the x-axis. Across or over, either one is okay, it's understood. Oh my gosh, why am I saying this graph is negative? Y'all are probably watching this video thinking, oh, I'm so sorry for the dog barking. If your ears are not bleeding yet, I accidentally messed up and I said this graph is negative. I don't know why. I really wanted it to be negative. So this one is positive, which means there is no change. Okay, y'all are probably thinking I was crazy there. And you know I am, just a little bit. Okay, so our A value here is 2. And when the number is greater than 1, we have a vertical stretch. So the graph is getting narrower. But the term we will use on all of the tests and quizzes is vertical stretch. So please use the correct vocabulary so that you have an understanding. Okay, now h. What is our h value here? Our h value is, well, there's no number in there, so h is 0. So no change. And k is +3. So we are going up 3. We shift up 3 units. So what is our vertex here? HK, which is 0, 3. Perfect. Okay, for this last one. All right, now this last one, is this positive or negative? Negative. Negative. It is reflecting. Oh, okay, I really can't spell tonight. Reflects over x-axis. Okay, now the a value, it is 2 over 3. And 2 over 3, is that greater than or less than 1? It is less than 1. So 2 over 3, because that is less than 1, we have a vertical compression or shrink, which means that's getting wider. Okay, so here we're going to say vertical compression. And the h, well, h here is -5. So if it's -5, we know it is actually +5, which means we are moving right 5. I'm going to say shifts right 5. Shifts right 5 units. That 5 kind of looks like an S, so I'm going to fix it. I know someone will complain about it. Okay, shifts right 5 units. All right, and the last one, K. There is no K value out to the right, so this is 0 change. No change. What is our vertex here? Remember, the vertex is HK, which is 5, 0. I'm going to write that at the top of our page just so you remember. Vertex H, K. Okay? Okay. All right, well, this concludes our notes for the day. Go ahead and pull out the practice sheet that you should have picked up from the front of the room. It is a quick little thing, so it shouldn't take you too long. Get that done and get that turned into the box. And then I will see you tomorrow, some of you tomorrow. Tomorrow's the PSAT. Remember, seniors don't need to show up until 12 p.m. Everybody else show up on time. All right, thanks, guys. Have a good night. Or good day. It's nighttime for me. Okay, bye.